Now that we have got our long section plotted on, the next thing we need to do is to move towards past 3E, which will be the final task of the piece of coursework. Now, as you can see, we've calculated our invert levels at P and R. Okay, but another useful purpose of a long section is that very quickly we can get a very good estimate as to invert levels anywhere along this line, because if you have a ruler or a scale ruler and you know that your datum line is 60, you measure up from your datum line. Okay, and we're going to do this at every 25-meter interval because we want to know the invert levels at every 25-meter interval for volume calculations. I'm going to use the distance tool and you are going to use your ruler. So you're measuring from your datum to bottom of your pipe. In my case it's 10.2. So we divide that by 2 to scale that, which will give us 5.1. Okay, so 60 plus 5.1 measurement will give us your 65.1. And basically you'll do that for the other two measurements as well, and yours will be individual there. Okay, so 9.8 divided by 2 gives us 60. Right, 64.9. And finally, you're just measuring from your datum to the underside of your pipe, half that measurement. Add it to 60. 7, 0. And basically then you have got your different invert levels along that section there. Now, they're going to be important because you're going to need those to move to the final part of this calculation. And we're going to do it on this sheet. Okay, so from the longitudinal section, at 25-meter intervals, calculate the following for material to be excavated if the proposed formation width is 0.7 meters wide with a gradient with side slopes of 35 degrees. So what you'll do is you will populate this table. You'll populate it with your reduced levels and your invert levels. Now I'm just going to use the first and last here as examples for you, and I've just shown you how we work out the rest there. Okay, so we're going to do some volume calculations for this here. So once you complete that table, knowing your reduced levels and invert levels, we can then figure out our depth of our excavation, and that's simply by taking away your formation level, or sorry, your invert level in that case. Formation level is another piece of terminology. So 68.171 minus 65.3 will give you 2.871. Similarly, I've done the same for the end one there, and your results may vary a little there. Okay. What we can do then is we can make a table like this here. Okay, and you're going to do this, draw this table out once by hand preferably, and complete these calculations. Okay, and I'm just going to run it through it with you here. Okay, so our depths. Okay, so we've already worked out our depths, so it's simply a matter of copying your depths from there right down to here. Okay, so your depth 2.871 at chain of 0. We'll do the same for this section, 1.501. Okay, now that is the depth of your excavation. Now, we were saying that our side slopes have a rectangle of 35 degrees. So we need to use a formula that is depth divided by tan 35. So your depth of 2.871 divided by tan 35 equals 4.100. Okay, and we can do the same for the bottom one just for another example. 1.501 divided by tan 35 is 2.14, and we'll round that up, 2.144. Okay. What we need to do here then is we have got our depth divided by tan 35. You've got this answer, and you're going to add the width of the trench as well. Now it states up here the trench width is 0.7 meters. So it'll be 4.1 plus 0.7. And that will give you 4.8. And again, I'll do that at the bottom here. 2.14 plus 0.7 is 2.844. Moving on to the final part of the calculation then. And basically it's going to be this figure here plus the original depth, or sorry, multiplied by the original depth. Okay, so it's going to be 4.8, which is all the working out that we've done there is in brackets there. 4.8 multiplied by 2.871. So 2.871 times 4.8, and that gives us a cross-sectional area of 13.78 on that round up there. And again, you'll do that right down the table to your final cross-section area of 2.844 multiplied by 1.501, and you'll get 4.26, and that rounds up to 9. So it's reasonably simple to complete that there, and that will give you the cross-sectional area of each railway cutting, or sorry, not railway cutting, but the drainage cutting every 25 meters. And that will then, once we know that there, then we can use those areas to use the Simpson's rule and the trapezoidal rule to complete our table then, or sorry, complete our volume calculations.